So, some of you may have noticed that I own a VR headset. And whenever I'm not dying in school making videos or programming some useless thing that my spontaneous ADHD mind decided to spend the next 20 hours on without it having any benefit to anyone, I'm usually playing Beat Saber. And since I spent the majority of online lessons during the quarantine playing it, I've become quite good at it. But I'm still nowhere near Matej's level. That guy is a psycho. Anyway, I've been wondering about how VR works for a while now. And since I know my way around 3D stuff, I decided to do some research and explain it in this video. If we don't count some obscure stuff, then there are two main runtimes used by VR these days. There's OpenVR and then there's Oculus VR. We're going to pretend that OpenXR doesn't exist. Thank you very much. OpenVR is used by Half-Life Alyx and most games on Steam. You can use almost all headsets with OpenVR, while on the other hand, Oculus VR is exclusive to Oculus headsets, and you cannot play Oculus games on your Steam VR or OpenVR headset. I wonder why that is. Anyway, we are going to use OpenVR for my little demonstration. First, we need to understand what a VR headset is. And for all intents and purposes, it's just a screen. I mean, it ends with a DisplayPort and a USB, but we can't see it as a display in Windows. Why is that? VR headsets use something called Direct Mode, which allows SteamVR to have full control over the headset and not let Windows's filthy hands touch it. Look, if I turn Direct Mode off, I can now see my VR headset as a display, and if I look into the lenses themselves, I just see my desktop. So, that's the display covered. But what's the USB for? Well, VR needs tracking to work. You need to send the positions of the headset and the controller through something. But that's not the only thing that needs to be pushed through the USB. You need to handle button presses, send audio to the headphones, send vibration data to the controllers, stream video from the headset's cameras with little to no latency, and so much more. That's why most VR headsets require you to use USB 3.0. It's just so much data. That's a lot of things to access and manage while programming a VR application. But thankfully Valve was kind enough to create a great API which is very human readable and easily implementable into existing game engines. So I just took the source code of an engine I developed a while ago and started coding. So first we need to initialize SteamVR. This launches SteamVR if it isn't already running and tells it that we are going to run an application. Now we need to set up the actual rendering. We're going to use OpenGL since I've been too lazy to learn Vulkan. To be able to render to a VR headset, we need to render every frame twice from two positions. OpenVR supplies us with the headset center position and the relative positions of the two eyes. So, we perform two translations of the geometry around the camera. First one for the left eye view and the second one for the right eye view. We have to move the geometry around because our graphics card has no idea what a camera is. It just knows where to put vertices on the screen. The normal thing would be to render into a window, but since our headset isn't a display in Windows, we have to render our frames into textures. You may know textures as the thing that gets wrapped around an object, but in the end it's just an image in video memory. So now that we have two textures ready, we can submit them to OpenVR, which passes them onto SteamVR, which sends them over to your headset. Since we have to render two frames, we can oversimplify that you need twice as much power to run a VR game. So now we can see our little cube in 3D in VR. But since the view doesn't move with my head, it gets pretty nauseating. And that's why we need tracking. And there are two main ways to accomplish VR tracking. The one I've got right here is called outside tracking. It consists of two base stations which emit sweeps of infrared light. If you take a real close look at the headset or the controllers, you can see subtle dots. These are infrared sensors, which detect the sweeps from the base stations and then use special algorithms to calculate the precise position of the headset based on when the sweep hit which sensors. These sweeps are done by little motors inside the base stations, and if you listen really closely, you can hear them start up. That's why they're also called lighthouses sometimes. They're basically just a spinning light. The other way of tracking is called inside out, and it is used by most headsets these days, mostly because it's cheaper. It consists of several cameras on the headset itself, which use image recognition algorithms to determine their position in 3D space. They also track the controllers by just searching for them in the camera footage. This method tends to be cheaper but has less precision. And it is also much easier because you don't have to lug these things around. Implementing this is once again very simple thanks to Valve. All we need to do is to run this function right here, which supplies us with the positions of our tracked devices in the form of a 4x4 matrix. So now we can update the position of our headset every frame, and I can now look around without having to reintroduce myself with my last meal. So now I can walk around and look at my scene, but we still can't see our controllers. Well, we can get their positions the same way we got the position of the headset, but how do we render them? SteamVR contains mesh data and textures of all the different controllers you can connect to it. And you can access this data with a simple function call. And now I can see my controllers. So, a new year came by. Another page of my YouTube channel has opened. We have grown into huge numbers, and we celebrated that accordingly on the New Year's stream. It was a pain to clean. There are a lot of projects this year that I want to share with you, so subscribe and stay tuned. Please, come and join my Discord server. There is an amazing community and you can get help with programming or basically anywhere else. You can even follow me on Instagram, because followers on Instagram get extra stuff from behind the scenes. Or you can support me on my newly created Patreon page. There is a $1 plan which gets your name written at the end of every video. Huge thanks to my Patreons, especially to Kogetsu. Is it how you spell that? And more thanks goes to Kuba and MiniStumpy, whose music you've been hearing this entire time. Thanks for watching, and I will see you in the next one. Nauč se mluvit, vole, nauč se anglicky, jsi úplnej kreten. Neumím mluvit, tyhle, proč dělám zase na YouTube, vole, ani neumím mluvit.